Hello, sir. My topic is block cipher modes of operation. Here there are five types of block cipher modes of operation. First one is electronic code book mode (ECB mode). Second one is cipher block chaining (CBC mode). Third one is cipher feedback mode (CFB mode). Fourth one is output feedback mode (OFB mode). And fifth and last one is counter mode (CTR mode). So first one is electronic code book mode (ECB mode). Here in electronic codebook mode is the easiest block cipher mode of functioning. Why it is easier? Because of direct encryption of each block of input plain text and output is in form of block of encrypted cipher text. Here 1-to-1 correspondence between the plain text block and cipher text block. For the same plain text block of mode, the same ciphertext block of mode is there. Generally, if a message is larger than b bits in size, it can be broken down into a bunch of blocks and the procedure is repeated. Here, for the sake of understanding, we can compare this electronic codebook mode with the Caesar cipher. In the Caesar cipher, there is a one-to-one correspondence or association between the plain text and ciphertext. Here is the same thing, but what is the difference between the Caesar cipher and this electronic codebook mode? Here in Caesar cipher we are using the plain text, but here we are taking block of plain text. Why it is called block cipher? Because here we are using the size of block cipher in plain text and ciphertext is same. Here is the figure is given in which we are taking plain text as an input with the key and we are performing encryption and we are getting the ciphertext. Same in the decryption, we are taking ciphertext with the key and we are doing decryption and we are getting plain text. There is no dependency between one block and another block. There is a one-to-one correspondence between and parallel processing is there. Advantage of using electronic codebook mode: parallel encryption of blocks of bit is possible, thus it is a faster way of encryption because there is a parallel processing is there, no dependency between the first block and the second block and other blocks. Disadvantage: prone to cryptanalysis since there is a direct relationship between the plain text and ciphertext. Cryptanalysis can easily code break and do perform traffic analysis and can understand the correspondence between the plain text and ciphertext, so it is very easy for the cryptanalysis. So it is not a very good thing because it's a basic mode. So let's see next mode is cipher block chaining (CBC mode). Cipher block chaining or CBC is an advancement mode. This is a better mode or advanced mode than our previous mode, electronic codebook mode. Why? Since ECB compromises some security requirements. Yeah, as we have seen, there is some compromise between the in ECB because there is a direct correspondence or association between the plain text and ciphertext. Here that not direct relationship or correspondence between. Why? Because in CBC the previous cipher block is given as input to the next encryption algorithm after XOR with the original plain text block. In a nutshell, here a cipher block is produced by encrypting an XOR output of the previous cipher block and present plain text block. Let's see the diagram. Here we are taking plain text and we are performing XOR with the new thing, that is initialization vector. Then we do encryption with the key. Then we get the ciphertext. Here we are using initialization vector, that is a random thing. And we are taking the first block of ciphertext as an input for the next XORing with the plain text of second block. Then we are performing encryption with the key, and then we are getting the ciphertext, and so on. We perform this thing again and again. So first thing is initialization vector, then we are performing XOR, and then we are taking the ciphertext of first block as input for the second. So some randomness is coming, so definitely it is better than the electronic codebook mode, because in electronic codebook mode we are not performing anything like XORing, we are not taking any initialization vector for the randomness, so there is a one-to-one correspondence between that. But here we are using initialization vector as well, we are performing XOR as well, we are taking the ciphertext of first block as an input for second block, so it is better than. Same for the decryption, we are taking ciphertext, we are performing decryption with the key, then we are taking initialization vector and we are performing XOR, then we are getting the plain text. So one thing it is notice here, that we are using initialization vector for the first encryption as well as first decryption. In other mode, in other levels or stages, we are not taking initialization vector, because we are taking the ciphertext of first stage or first block as an initialization vector for the second stage and second block, and so on. So ciphertext acting or working as an initialization vector for the other levels except first level. Advantage of cipher block chaining. Cipher block chaining works well for input greater than b bits. CBC is a good authentication mechanism. Cipher block chaining is a good authentication mechanism, as we have seen, better than the electronic codebook mode. Better resistive nature toward cryptanalysis than ECB. Yeah, because in ECB cryptanalysis can easily understand, but here CBC, because of initialization vector, because of XORing, there is some randomness, so cryptanalysis can't easily understand and can't code break. Disadvantage of cipher block chaining. Parallel encryption is not possible here, since every encryption requires a previous cipher. Yeah, because there is a association or dependency between every levels, because as we have seen, we are using the first level block cipher as an input for the second block as an initialization vector, so dependency is there. Third one is cipher feedback mode. In this mode, cipher is given as feedback. As its name suggests, we are taking cipher as an feedback to the next block of encryption with some new specification, as we have also done in previous, that is a cipher block chaining mode. But here some modification is done. First, an initialization vector is used for first encryption, and output bits are divided as of set of S bits and BS bits. The left hand side as bits are selected and are applied an XOR operation with plain text bits. The result is given as input to a shift register and the process continues. The encryption and decryption for the same is shown below. Both of them use encryption algorithm. Here we are taking initialization vector, we are performing encryption with the key, then we are getting S bits and BS bits. We are dividing in two parts, S bits and B minus S bits. Then we are taking S bits and we are performing XORing with the plain text. Then we are getting ciphertext. Here one thing is notice, we are not taking plain text, we are taking initialization vector with the key. Then we are performing encryption, then whatever S bits output we get, we divide in S bits and B minus S bit, because total is B bits. Then we are performing XOR with the plain text, then we are getting the ciphertext. And the output of ciphertext is given to the input to the shift register. Same total B bits, we take S bits and B minus S bits. Then we take B minus S bits and we perform encryption with the key. Then again we get S bits or B minus S bit. Then we are taking S bits again with the plain text of second. Then we are performing XOR and we are getting the ciphertext of second block, and so on. This happen again and again recursively. In decryption, we are taking initialization vector, then we perform encryption with the key, then we get b bits, we divide in two parts, s bits and b minus s bits, then we perform XOR with the plain text, then we get ciphertext. This process will recursively happen. Will first block of ciphertext will go in shift register, and second block same thing happen, s bits b minus s bits, we take b minus s bits and we perform encryption with the key, then s bits and b minus s bit we get we perform XOR with the plain text of second block and we ciphertext. Here one thing is notice that we are performing encryption process in encryption as well as decryption, so we are performing the same thing. Next, out advantage of cipher feedback mode, CFB mode. Since there is some data loss due to use of shift register, thus it is difficult to applying cryptanalysis. As we have seen, we are using the shift register here. We are using the initialization vector as well as we are using the shift register. So because of shift register there is some loss happen, so it is very difficult for the cryptanalysis to easily code break. So we are using initialization vector, we are using shift register, then we are performing bits in two parts, as bits b minus s bits, performing XOR, and so randomness is there. Advantage we have seen. Then next mode is output feedback mode. The output feedback mode follows nearly the same process as cipher feedback mode. There are very similarities between the cipher feedback mode and output feedback mode. There is a very few difference. Mode except that it sends the encrypted output as feedback instead of the actual cipher, which is XOR input. In previous cipher feedback mode, we are taking the output of cipher in input in second, but here we will take the output of encryption. We will see. In this output feedback mode, all bits of blocks are sent instead of sending selected as bits. In cipher feedback mode, we are only taking the as bits, but here we will send entire b bits, all bits. The output feedback mode of block cipher holds great resistance toward bit transmission error. It also decreases the dependency or relationship of the cipher on the plain text. See, here initialization vector, then we perform encryption with the key. Whatever output will come, we perform XOR with the plain text, then we get the ciphertext. Here we are taking the output of encryption as an input for the second level. We are not taking the cipher text as an input for the second level as we are taking in the cipher feedback mode. That's why output of encryption we are taking as an input for the second level. That's why it is called as output feedback mode. Here output of encryption is performing the feedback for the second level. Same thing, we are performing encryption for both encryption as well as decryption. There is no change. Just in encryption we are taking the plain text, we are getting ciphertext. Here we are taking ciphertext, we are getting plain text. But output is the same for encryption and decryption. We are taking the output of encryption as the input for the second level in both encryption as well as decryption. Advantage of output feedback mode. In this case of cipher feedback mode, a single bit error is a block is propagated to all subsequent blocks. This problem is solved by output feedback mode, that is free from bit errors and in the plain text block. In the cipher feedback mode, if a single bit error will occur in one level, so that error will be propagate to all subsequent error, but that problem is resolved by output feedback mode. Last mode is counter mode. The counter mode or CTR is a simple counter based block cipher implementation. Every time a counter initiated value is encrypted and given as input to XOR with the plain text, which results as a ciphertext in the CTR mode is independent of feedback. Here there is a no feedback use and thus can be implemented parallel. No feedback, so we can do it parallelly. But here we are using a new thing, that is counter. Let's see. In encryption, we are taking the counter as an input with the key, then we perform encryption. and we perform XOR, output of encryption XOR with the plain text, we are getting the ciphertext. Same in all level. And decryption, we take counter value, and we perform encryption with the key. Whatever output will come, we take XOR with the ciphertext, and we get the plain text. So this counter mode is somewhere, not exactly, but somewhere it is equivalent to the electronic codebook mode, but there is a difference. Here we are using the counter. In electronic codebook mode, there is a one-to-one correspondence between the plain text and ciphertext, but here in counter mode we are using the random values of counter, because the counter value of any level is not depend or associate with each other. All values of counters of each levels are independent. So because of this, counter randomness will come. Advantage of counter mode, since there is a direct different counter value for each block. Every block counter value is different. This is a very important thing. The direct plain text and ciphertext relationship is avoided. Here there is a no direct relationship between the plain text and the ciphertext, that is in the electronic codebook mode. This means that the same plain text can map to different ciphertext. In electronic codebook mode, there is a direct one-to-one communication between the plain text and ciphertext, but here it's not, because of the randomness or different value of the counters. Parallel execution of encryption is possible, as output from previous stages are not changed as the input of case of CVC. In cipher block chaining mode, we are performing the chaining, and we are taking the output of one level of cipher is an input for other level, so there is a no parallel processing is there, but yeah, here it's possible. So thank you.